Hey there, you're listening to the K-2 Just in Time for Forms of Energy. Um, I just wanted to start out by giving you an overview of what we hope to accomplish with this. The first thing that I want to do is give you some background information and talk about some common misconceptions about light, sound, and thermal energy. Also, want to highlight a lesson from the units and also put in a plug for the live Q&A that is on September 28th at 3 o'clock p.m. That's tomorrow. Um, it lasts, I think, until 4:30. So it's a come and go. If you have any questions about the upcoming units or about just science in general, feel free to pop in whenever you want and chat with me. My name is Eskia Little, by the way, if you didn't know. Just feel free to chat with me at any time. So we're going to dig right in, starting with the topic of light. There's five misconceptions that I want to kind of briefly talk about before we jump into the unit. And that the first misconception is that light is only found in bright areas. Now, in everyday context, when we talk about light, we're usually referring to how bright a particular place is. Such as we need more light in here, or is it light outside yet? And because of this, students' understanding sometimes conflict with the scientific idea of light that we want to teach them, and that is as a form of energy that travels from one place to another. Um, if you think about holding a flashlight in a dark room at a wall, um, we see the circle on the flat wall that represents where the light is hitting. However, we're not able to see the beam making its way across the room because light travels at such a fast speed. Um, Even if children understand that light's made up of traveling rays, they can still hold the misconception that light only exists in bright areas. For example, in a room lit by a single candle, they may say that light only travels as far as the objects that are lit by the candle, and it doesn't go into the dark corners of the room. The fact that a person is still able to see a candle, even if they stand in a dark corner of the room, means that light rays must have flooded the entire room. So, how can we overcome this particular misconception? How can we reconstruct this with students? One way to do that is just to do that. Light a candle in a dark classroom and ask the class to draw how far they think the light has traveled, and then send some of the children into the dark areas of the room and ask them if they can see the candle, and explain that if they can, some of the light must still be reaching these dark areas because seeing the candle means its light entered their eyes. I would also mention that if light did not travel very far from its source, we would be unable to see the distant stars, which are billions of kilometers and miles away from the Earth. So the second misconception that I want to talk about light is that we see things because light travels from our eyes towards an object. Now, children usually draw light rays in a way that suggests that they believe that the reason we see things is because light travels outwards from our eyes and connects with the object. This is called the active eye model. However, the reverse of that is true. We see an object because the eye is able to absorb light rays traveling from the object. And these light rays create electrical and chemical signals within our eyes that are sent to the brain. Therefore, the correct way to draw light rays is moving away from an object towards the eye. However, this is only part of the story. We can only see an object when it is illuminated by a light source, such as an electric bulb or the sun, as the object itself can't generate any light rays. So, some children have problems with the idea that light can reflect off non shiny surfaces, thinking that reflection only takes place with mirrors, plain glass, and water. There's also misconceptions related to the source of light, including that no source is required in order to see an object. Thus, like humans can just about see anything in total darkness. That is a misconception. So, how can we begin to reconstruct this misconception for students? Early on in this topic, we definitely need to get children in the habit of including the light source in their diagrams, whatever that light source may be, whether it's a lamp, whether it's the sun, whatever the light source, it needs to be included. This will help underline the idea that the reason why we can see something is that light from a source reflects from the object's surface and into our eyes. Children need to think of this journey being taken by one continuous ray of light from source to eye. Um, Research has also shown that children can understand the scientific model more easily if the object is replaced by a mirror and if they're asked to draw the journey of the light rays. Use a candle as the source, not the sun. Teacher can demonstrate more clearly if a laser pen is used as the source and the beam sprinkled with flour. But it's, of course, obviously more important for safety reasons not to view the beam's reflection as well. So, one other thing, we can ask children to draw and color examples of things that can make their own light and things that cannot make their own light. So that those are just some ways to help reconstruct that misconception in students.